Right, so we're going to look at the divisor of a line segment. So this obviously is something that's new in terms of leaving cert content. So when we're dividing a line segment, we have two ways of doing it. And the first way is using a formula that I'm going to show to you. And the second way is what we call a translation. Translation is to do with moving points from one place to another place by a certain amount. And in terms of what we're looking at, it's going to be a particular ratio. So in terms of the formula is given here as it appears in the log tables. And this formula in the log tables is given as a point dividing the line segment PQ, where P and Q are as labelled below here. So P is x1, y1, Q is x2, y2. The ratio is A is to B. So the ratio is generally given in the question, or you might have to manipulate or so on and so forth, depending on what the question is, I suppose. But you can see in terms of once you're given all that information, it's just a matter of subbing into the formula. So we'll see how that looks with this example below here. So we're given again our ratio 2:1, we're given our 2 points. So we simply sub into our formula, noting as well that I suppose it kind of feels a little bit backwards that it's the second part of the ratio that comes first in the formula. So it's just making sure, I suppose, that we are happy with that as well, that we can kind of follow that. Okay. And same thing applies then for the next bit. So B, y1 plus A, y2. Okay, 7 over 3 and minus 1 over 3. So 7 over 3 and minus 1 over 3 as our answer. So that is the point that divides this particular line segment into this particular ratio. Okay, so looking at the next point then, we're looking to find the ratio given the dividing point that we have to use. So let's have a look at this one. So again, we're given the 2 points, we're given the dividing point, and we want to try and figure out what this ratio is. So what we're probably going to end up with is a point where we'll have maybe h is equal to a certain number of k, and we'll be able to, from that, just kind of ascertain what is the ratio of h's to k. And then that's what we use then as our answer. There's also a second way of doing this, which we might look at when we've looked at translating the points. We'll maybe come back to this example again. But looking at it in terms of using the formula, so obviously I don't know what my h and k are, but I can sub them in to my formula. So k by minus 3 h by 0 k plus h. Okay, and obviously we know that the answer here is 2 minus 2. So we can use that in our calculations. So 4k minus 2h over k plus h and minus 3k over k plus h. And it's equal to 2 and minus 2. So taking each of these points, we'll focus on this point first, and it is equal to 2. So 4k minus 3h over k plus h is equal to 2. So 4k minus 3h is equal to 2k plus 2h. And then trying to just kind of reorganize this as best we can, we get that 2k is equal to, let me see, make sure I haven't made any slips. I have made a slip there, I see already. This should be 2h. So where I got 3 from. 2h, so we get then that 2k is equal to 4h, which of course means that k is equal to 2h. Now we'll solve using the y coordinates as well, just to see whether we get the same type of ratio. So we get minus 3k is equal to minus 2k minus 2h, which gives me that minus k is equal to minus 2h, or of course k is equal to 2h. Now if we were to rewrite this, I suppose, as a ratio, maybe writing, h over k, like I suppose generally talking about it here, the ratio that we have is that k is twice as big as h. So k would be twice as big as h. So if h is 1, k is 2, which would mean that my ratio is going to be 1 is to 2. Okay, so that's kind of what we're getting at here. If we were maybe to just rewrite it, we get that h over k is equal to 1 over 2. And again, the same idea goes here. So then h to k becomes 1 is to 2. terms of that kind of idea of moving from fraction to ratio and the kind of relationship there. So that ends up being our ratio as 1 is to 2. It's a 1 is to 2 ratio. So this line segment splits our line in kind of thirds, 1/3 and 2/3 then. We look at another method of doing that then when we look at dividing the line segment via translation when we finish this section. But as I kind of said at the start there, translating a point means to move the point. And to move a point, we will look at a particular translation or movement that's required for the x coordinate and for the y coordinate. And then we can apply that then to further points. Or if we're trying to follow a ratio, we might see that I need to move the x coordinate 4 units in order to reach the next coordinate that I want. But in terms of my ratio then, the next move that I need to make might be half of that. So instead of moving it 4, I might only move it 2 for the next segment. So that's the kind of ideas that we're going to be looking at. So if we look at, say, this point here, if A is 3, 5 and B is 7, 2, then the translation that maps A to B is given by +4, and this is in terms of the x coordinate, and then -3 in terms of the y coordinate. So to move A to B, I would have to add 4 to the x coordinate and take away 3 from the y coordinate. And as I was saying there, if we are given the ratio into which the line segment is to be divided, we can apply this ratio to the translation and then find the coordinates of the dividing point. So say, for example, we're looking at that AB again, and we're saying it's going to be divided in this ratio here, 3 is to 2. So we already know that there is a particular line segment with A at one end and B at another end. And we know the translation that maps A onto B. And what we want to do is we want to try and divide that line segment into a 3 is to 2 ratio. We want to know what this point here would be. We could call it P, for example, or D actually is what I've called it here. So we'll stick with that. So what we might try and do then is, given that we know the translation that takes A to B, we'll apply the ratio to that. So if it's going to be divided in a 3 is to 2 ratio, then that means we're dividing our line segment into fifths. And one part is 3/5 and the other part is 2/5. And the fifths there is coming from the 3 plus 2, it's 5. So the dividing point should be 3/5 of the way from A to B. So obviously the whole way we already know, but we want to work out now what would 3/5 of the way be. So instead of adding 4, like we did in the first place, we're just going to add 3/5 of that, which is 2.4. So we add on 2.4 and we get that D would be 5.4. And the same thing goes for the Y translation. So instead of doing the full Y translation, the -3, we'll just do 3/5 of it. So we'll take away a 4.5 instead. And we get that D is 5.4, 0.5. And in the same way, if we were given the dividing point, we can then use the ratio to find either of the endpoints if we need to. So looking at this example here, so we're trying to find the dividing point using a translation. So A is 2 minus 3 and B is xy. The point C divides A, B into a particular ratio of 3 is to 2. Find the values of x and y by translation. So actually this one we're looking for the endpoint. So let's kind of set up our question if we like. We'll just kind of get a sense of what we're looking at. So A is here, 2 minus 3. B is here, xy. And C is somewhere around here. It's probably not entirely accurate, but somewhere around here. This is divided in a 3 is to 2 ratio. So in order for us to solve this question, we need to first work out the translation that takes me from A to C. So looking at the x coordinate first, to go from 2 up to 5, I would obviously have to, let me use a different color here maybe. So from 2 to 5, I would have to add on 3. And then to go from -3 to +3, I would have to add on 6. So let's just kind of make that a little bit cleaner, I suppose. So if I'm looking at marking out my translation is going to be +3 in the x coordinate and +6 in the y coordinate. And that's how I get from A to C. Okay, now we note as well that in terms of my ratio is 3 parts of my ratio. Okay, so in order to go from C to B, I only need to go kind of 2 parts. Okay, so we would consider that 3/5 of the way is 3, and 3/5 in terms of the x coordinate is going to be the +6. I want to know what 2/5 are, so let's find 1/5 first. So 1/5 of my translation is 1, and 1/5 of the way in terms of the y coordinate would be 2. So the 2/5 that I need to go is going to be a +2, and over here it's going to be a +4. So let's apply that now to my new translation here. So we'll use that same purple color. So this time in the x coordinate, we're only going to add on 2. And on the y coordinate, we're only going to add on 4. So where the first time was 3, then this ratio is 2. So that leaves us with coordinates of b being 7, 7. Okay, nice, straightforward, 7, 7. And if you notice even as well, the 2 points that we've had here, so the x coordinate, the +3 became +2, which follows that same ratio, 3:2. And the same way the y coordinates, that +6 became +4, which if we break it down, follows the same ratio. So the translation we're making should follow the ratio that we're given. Okay, so a lot of this requires you to have that little bit of a think about your ratios and kind of coming back and making sure you understand those, okay? So let's look at, or I said I'd go back and do that same example, maybe using the ratios. So let's try and do that. The same idea is going to happen here, but this time we're given all the points and we want to look for the ratio. So let's set up my diagram here. So if I start with A, I have C somewhere along here, and I have B here, and I can lay out my points as well. So A is 4 minus 3, C is 2 minus 2, and B is -2, 0. So let's work out these translations. So to go from A to C, I would need to go -2 on the x coordinate, and I would need to go +1 on the y coordinate. Okay, applying the same idea now to C is to B. Again, I would need to go, so here I need to go -4 on the x coordinate, and I need to go +2 on the y coordinate. So lining those up there, if we take the x parts first, -2 is to -4, which of course gives me 1:2. And the same thing occurs with the y coordinates. I get a ratio of 1:2, which suggests to me then that h is to k is equal to a ratio of 1:2. And that's the same as we had from the first part. Now obviously you can see there, if you can get a handle on these translation ones, they're actually quite a bit easier than the other way than using the formula. If you can do it with the translation, you can save yourself a bit of time. The translation ones also come up a little bit when we look at the circle as well. So it's one to get a good handle on if you can, working out how these things are related in terms of ratios. So looking then at some of these exam questions, we have 2 exam questions here to look at. So the points A and B are the endpoints of the line segment AB. Find the coordinates of the point C, which divides AB internally in the ratio 4:1. It's quite a nice question, really. All that they're requiring you to do is to use your formula. They've given us all the information. So again, as we've been saying, we'll start by writing out our formula and giving ourselves those marks there. So 1/8 plus 4 by -1 all over 1 plus 4. The same thing here, 1 by -4 plus 4 by 3, 1 plus 4. 8 minus 4 over 5, -4 plus 12 over 5. And we get 4 over 5, 8 over 5. That's our answer there. 4 over 5, 8 over 5. Okay. Looking at the next part then, so this is an exam style question where we're given the points A and B, we're given the point C that divides the line segment into a particular ratio, and we're asked to find the ratio. So we've our 2 ways of doing this here. Obviously we've kind of said the translation method is really the easiest one there, so maybe we'll start with that one. So here I have A, here I have, we'll say C, and then here I have B. So my point C is 1, 0, my point B here is 3 minus 1, My point A is minus 5, 3. So let's have a look at going from A to C. I need to add 6 to the x coordinate, and I take away 3 from the y coordinate. Then looking at going from C to B, then I would add 2 to my x coordinate, and to my y coordinate I take away 1. Okay, putting these ratios together, then 6 is to 2 can of course be broken down to 3 is to 1, and in the same way my minus 3 is to minus 1 can be simplified to 3 is to 1 then. So it makes it just a bit easier for us really to stick with that translation one. So I suppose generally it's making sure you're happy with that formula, that you're happy with the translations, and that you can make those adjustments for yourselves then.